All right, let's get right into it. We're tackling a topic that has set the AI world on fire, the illusion of AI's limits. We're going to explore this really provocative idea about how we measure, or maybe how we mismeasure, the true reasoning power of artificial intelligence. So it really all boils down to this one huge question. Do the most advanced AI models actually think? I mean, when we give them a really tricky problem, are they genuinely reasoning it out, step by step, like a person would? Well, a fascinating, fast and furious academic debate just tried to get to the bottom of that, and wow, the back and forth is something else. Okay, so here's where the story begins. A new study comes out, and it reports what looks like a shocking failure in AI reasoning. It all kicked off with a paper that had a pretty provocative title, The Illusion of Thinking. Researchers wanted to test these big AI models, they call them large reasoning models, by giving them puzzles that get harder and harder. And what they found, well, let's just say it was dramatic. So take a look at this. They used this classic puzzle, the Tower of Hanoi. You might have played with it. The AI was doing great, 80% accuracy all the way up to 7 disks. But then, look what happens. As soon as they added just one more disk to make it 8, the accuracy didn't just dip, it completely plummeted. I'm talking straight to 0. It fell off a cliff, a total reasoning collapse. It's wild. Yeah, the researchers' conclusion was, pretty blunt. They said its performance was, and I'm quoting here, collapsing to 0 beyond a certain complexity threshold. So the takeaway seemed pretty clear. Maybe even our most powerful, most elite AIs have some kind of fundamental flaw, like maybe they just can't handle problems that require a lot of logical steps. But wait, it gets even weirder. This is the part that really baffled everyone. You'd think, right, that as the puzzles get tougher, the AI would try harder. Use more brain power, or in its case, more tokens, before it gives up. But they found the exact opposite. Right at that breaking point, the model started to think less. They used fewer resources before just failing. It made no sense at all. Okay, but just when you think you've figured it out, the story takes a sharp turn. Because almost immediately, another paper drops. And you gotta love the title, the illusion of thinking. So clever. And their whole argument? The AI wasn't broken, the test was broken. The problem wasn't the AI's reasoning, it was the experiment itself. So the rebuttal team pointed to 3 what they called fatal flaws in that first study. First, they said the original researchers completely ignored these things called token limits. Second, the way they were grading the AI's answers was just wrong. And third, and this one is the real kicker, they were testing the AI on puzzles that were literally impossible to solve. No, seriously. Let's break that first one down. The token limit. What is that? Well, think of it like a strict word count for the AI's response. For that Tower of Hanoi puzzle, once you get to 8 disks or more, the full, correct, step-by-step solution is just incredibly long. It actually required more words, or tokens, than the AI was even allowed to write in one go. It's exactly like asking someone to write an entire novel on the back of a postcard. It's just not going to fit. And here's the craziest part. The AI was practically screaming for help. In its own responses, it would start writing out the correct answer, and then it would literally say something like, "The pattern continues, but to avoid making this too long, I'll stop here." It was basically telling the researchers, hey, I know the rest of the answer, but you've put me in a straitjacket here with this token limit. But the original study's grading system was totally automated, so it just saw an incomplete answer and marked it wrong. It completely missed this crucial clue. But honestly, the token limit thing, that wasn't even the biggest issue. This is where we get to the really critical error in the experiment. The rebuttal paper looked at another type of puzzle the first team used, these river crossing puzzles. So the original studies set up these logic puzzles, getting people across a river with certain rules. And they specifically tested the AI on scenarios with 6 or more pairs of people. And here it is, that version of the puzzle with 6 or more pairs, it's mathematically impossible to solve. It can't be done. The AI models weren't having a reasoning collapse, they were just being smart enough not to solve an unsolvable problem. It's like, giving a calculator a divide by 0 problem and then marking it as broken when it gives you an error. It was a completely unfair test. So case closed, right? The first study was just flawed. Well, not so fast. Because then a third analysis comes along. And this one argues that actually the truth is somewhere in the middle. It suggests that both sides were kind of right and also kind of wrong. The real answer is a lot more nuanced. This third paper makes a really brilliant distinction. It says,
hey, you guys are talking past each other because you're running two totally different kinds of tests. Think of it like this. One test is about knowing a recipe for a really complicated dish. That's a test of knowledge retrieval. The other test is about actually cooking that dish flawlessly for 1,000 people. That's a test of sustained execution. See the difference?
Right, so when the critique paper asked the AI to simply write a chunk of code that could solve the puzzle, the AI nailed it. But of course it did. That's just asking for the recipe, which is a test of knowledge, something these models are amazing at. It's way, way easier than actually having to write out every single one of the, 32,000 plus moves to solve it? And this is where it all comes together. The original study, yes, it was deeply flawed, but it accidentally highlighted a real weakness. That dramatic collapse was an illusion for sure, but it pointed to something real, a kind of brittleness when it comes to long, step-by-step tasks that demand high precision. The AI knows the recipe, but it's not a master chef. It can struggle with the execution, especially over a really long cook time.
So, what's the big picture here? After all this academic sparring, what's the ultimate takeaway? Well, it turns out this whole debate reveals a much deeper limitation, not just in the AI, but in how we even think about testing it. So let's put it all together. What have we learned? First, that big accuracy collapse was pretty much an illusion created by some seriously flawed tests. But, and this is a big but, it did accidentally shine a light on a real weakness. AI can be pretty brittle when it has to follow a long, long series of steps perfectly. Its performance really depends on stuff like token limits and how familiar it is with a problem. And maybe the most important lesson of all is that the real challenge isn't just about the AI itself, but about us, about how we design fair tests to measure it in the first place. And that really leaves us with this huge, lingering question, doesn't it? How do you fairly test a mind that works so differently from our own? It's a real puzzle. And figuring that out is going to be just as important as building the AI itself. Definitely something to chew on.